So the first thing, basically direct variation, what it is implying is that as one variable gets larger, so does another. And the converse of that, as one variable gets smaller, so does another. So let's just real quickly come up with that definition. It's direct variation as one variable gets bigger, and then the opposite of that would be as one variable gets smaller. Okay, so the variables are moving in the same direction. That's what it means for variables to vary directly. Indirect variation, which we won't get to, that would just be the opposite. So one variable gets bigger, the other gets smaller, and vice versa. Now, based on this property, we times x, or another form of that is y divided by x equals k. And within that equation, x represents the inputs, y represents the outputs, and the variation. Okay, so you only need to write down what I've underlined there. It simply is just a linear equation, or a linear function. Okay, linear being those lines. On linear functions, so remind you about slope, how to graph an equation. Most of it ends up dealing with just simply slope. So this is a good introduction. Doing some work within that. All right. After you jot down all of that, we are so again, add in those tables. I'll give you a sec to do that. Okay, so with these tables, our task is to determine whether y varies directly with x. If it does, we're going to identify the constant of variation. Write an equation if it does vary directly with x. So first we have to check that. Does y vary directly with x? And that needs to be true for every single point. We find it by taking y divided by x, and if it does vary directly with x, that would mean we get the same value of k for every set of x and y coordinates. So we're going to just check, do we get 2 every single time? 6 divided by 3, that's also 2. And then 8 divided by 4, that's also 2. So since we get 2 every single time, that means that k equals 2. And thus our equation is just simply y equals 2x. Okay, in our direct variation equations, there's always y, constant of variation. All right, so now for part B, when I go to check for the same thing, and I take y divided by x, I get 4 divided by 1, which is 4. 8 divided by 2, which is also 4. But then I get 11 divided by 3. That clearly is not 4. In fact, that would be 3.66. And because we get a different value for y divided by x there, that just simply means y does not vary directly with x. So y does not vary. That's not how you spell vary with x. Or was that right the first time? Whatever. You get the point. I was right the first time. Vary. Exactly. V-A-R-Y. The I-E didn't look right. But the Y doesn't look right either. 1R? How about with 6 R's? There we go. Y does not vary with X. We get the point. Okay? All right. So now, this actually is all the information that you need to be able to work with direct variation problems. We'll go through others, but one thing that I'm hoping to just train you all to do and to get you more comfortable doing is approaching new math problems. Meaning a lot of us, when we see a math problem, if we don't recognize it, we say, oh, I don't know how to do it. Well, you might know how to do it. You just need to learn how to come up with a plan. What tools, what resources do I know about this particular problem, and how can I solve things from there? That's a lot of why I use Math Excel, because it puts you in those positions where you have to solve and work with problems that aren't directly related with what we did in class. So I'm going to continue to try to give you skills that when you see a problem that you've never done before, how can you actually solve it? So the reason I bring that up is because with this next problem, I think they do a really good job, this was pulled from our textbook, of coming up with a plan to approach new problems. And so this new problem, which again, you have all the tools to be able to solve it as of now, reads, suppose y varies directly with x, and y equals 9, and x equals negative 15. So what is y when x equals 21? If I saw this problem, and I have never seen this before, one thing that I think about, and some of us might help to write down, is what do I know? Based on what's given here and what I know about direct variation, what are some things that can help me start to come up with a plan? Well, I know that y varies directly with x. That's really important because that means y divided by x is going to equal some constant of variation. And that's what that next part is saying. Y divided by x is constant. So I'm like, okay, what do I need? What am I solving? What is this asking? It's asking for the y value when x is 21. All right, so what's a plan that I can do for that? Well, I can set up two different equations for y divided by x, or two different expressions for y divided by x, and then solve for the remaining variable. Okay, so this is a really good way to approach new problems. What do you know? What do you need? And then can you use that information to come up with a plan? Okay, I will especially push us to do this when we see word problems, but for any new problem, make a list. What do you know? What do you need? And then how can you come up with a plan from that? So right now, we are going to use that y divided by x and the fact that it's constant for every value to solve here. So I'm going to take the given y and x value, so 9 divided by negative 15, and I'm going to set that equal to the y that we're solving for divided by its corresponding x, which is 21. This is a proportion. All proportions are, they're ratios. With both of those are fancy words for fractions. When you have fractions or ratios or proportions equal to each other, that's when you would cross multiply. Okay, which a lot of you, when you see fractions, that's usually the first thing you want to do, is you want to cross multiply. This is the case where we actually would do that. Now, instead of me just straight up cross multiplying, I'm going to explain what cross multiplying is doing, because I think that's important for us to understand, because then you're not going to always think, oh yeah, I got to cross multiply here. Cross multiplying is just a way for us to undo all of the division in one step. So this is 9 divided by negative 15. So I can multiply both sides by negative 15. That gets rid of this dividing. So the left side is 9, and it equals, I got to multiply these fractions. So negative 15 times y is negative 15y. 21 times 1 is 21. Then I have some more dividing to undo because I have negative 15y divided by 21. So I'm going to multiply by 21 on both sides. That gets rid of the dividing. So I get negative 15y equals 21 times 9, which is 189. So cross multiplying, that just accomplished us going from the start of this equation to this part in one single step. Okay, it's just you undoing the division in one go. So negative 15 times y, we have that. 9 times 21, we have that. Okay, so feel free to cross multiply when you have these proportions equal to each other. And now that leaves us with one last thing we need to do to get y by itself. That's to divide by negative 15. So y equals 189 divided by negative 15. Now here's a MathXL trick and also kind of annoying piece about it. Even though this answer is correct, MathXL will not accept that. It wants you to reduce down fractions, and that'll always be the case, which is good practice for us. So let's talk about reducing fractions real fast. This is kind of a side note. So reducing fractions. Reducing fractions means to basically find a similar form of a fraction with its smallest numbers in your numerator and denominator. So an example would be like 21/14. 21/14 is not the smallest version of this particular value. For us to reduce it, we ask ourselves what divides the numerator and the denominator. And we're just going to keep finding numbers that divide the top and bottom until we cannot find any others. If you find the biggest number to start, then it's just a one-step process. But sometimes you might have to divide a number from the top and the bottom multiple times to truly get it reduced down. So 21 and 14, they're both divisible by 7. So I divide the numerator of 21 by 7 to get 3, and the denominator by 7 to get 2, giving me 3 halves. So 21/14 is equivalent to 3 halves, where 3 halves is the most reduced version of that. You will always need to reduce fractions when working with MathXL. So now, 189 divided by negative 15. There's nothing very obvious about what divides the top and the bottom. When that's the case, the calculators can actually help us do this. And I want to walk us through that right now. So why don't go grab a calculator. Try to at least have 1, if not 2 calculators per group. Every calculator can take a fraction and can reduce it down. Okay. First thing that we need to do is we need to take that particular fraction and we need to convert it into its decimal form, which means we just do the division. The numerator divided by the denominator is going to give it to us as a decimal, negative 12.6. The next thing that we're going to do is if you're using the graphing calculator, so the TI-84 or 83 or any other version of the TI, you're going to look for this button that says Math. When you click that Math button, the very first option is frac, meaning take the previous decimal and convert it to a fraction. So you'll always hear me when I'm telling you to do this. You're going to hear me say press Math, enter, and then enter one more time, and it reduced that fraction down for us, saying that it is negative 63/5. And so essentially, we divided the top and the bottom by 3 to get that. Now, for those of you that have a scientific calculator like this one right here, you're instead going to look for a button that has an F to a D. Okay, it's some form of that. Most everybody that has these scientific calculators, you should see this F to D button. So if we go ahead and just press that right now, this calculator is actually displaying the answer as a mixed number, which is pretty gross. I was trying to help somebody in the last class to get rid of that. The only way that I found to do that was to basically do the same thing. There's another button that says the A times B divided by C and convert it to D divided by E. So I'm just going to press that button one more time. And that's how you get to the negative 63/5. If you cannot find that button, or if you're having issues, once we're done with these notes, I will walk around and I'm going to actually ask you all, hey, did you get the calculator to work? If not, tell me and I'll help you figure it out. Okay? Because again, when I remember doing math in high school and even in college, I remember doing this all the stinking time. Okay? Reducing fractions on the calculators, especially when you're working with big numbers. All right. Any questions about the problem? Calculator questions, I'm going to come work with you individually. All right, well, then let's have you all do this next example. Same idea. Suppose y varies directly with x. Y equals 15, x is 3. What is y when x equals 12? All right. So after setting up your proportion, you get that 15 over 3 equals y over 12. You could go ahead and do that division. 15 is divisible by 3. You could say 5 equals y divided by 12. It's fine. You're going to get to the same answer regardless. I just cross multiplied, so 15 times 12, y times 3. That's 180 equals 3y divided by 3. Y is 60. Okay, well, I got one last thing for us, and it's real quick, more of a reminder about how we graph lines, which will be something you're going to do tomorrow, or we'll see you all tomorrow. Wednesday, Thursday. Okay, but the graph of a direct variation function is always a line through the origin. I basically touched on that when I introduced the direct variation by letting you know that this is linear. Because it's just y equals kx, and we're not adding or subtracting any value, that's how we can decide that it just passes through the origin. Okay, so when we're graphing anything, like let's say we're asked to graph y equals 3/4 x. A lot of us forget how to graph. There's always rules, and some of us are good with those rules. Some of us are like, hey, I can never remember those. Well, when in doubt, if you don't remember the rule to graph a line, just make a table of values. Take an x value, plug it in the equation, and get its corresponding y. Okay, so in this case, I'm going to pretend like I totally forgot how to graph a line. So all I'm going to do is take my x's. I already found the y's. I'm going to plot each point and connect the points to come up with the graph. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 4, 3, right? 1, 2, 3, 4, up, 1, 2, 3. 8, 6, so 5, 6, 7, 8, 1, 2, 3, 4, 5, 6. And then 12, 9, so 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. And it should be a line. Anytime that you're kind of hand drawing these graphs without graph paper, it's not going to be perfectly straight, and that's okay. All right, so when in doubt, make a table of values, plot the points. Now, real quick, let's actually remind ourselves how we would graph this with the rules. So we're going to ignore this table here. And I'm going to work to graph y equals negative 2x. Well, this being negative, it's actually going to go down into this fourth quadrant here. And it starts with 0, 0. And then we're just going to use the slope. So remember that a slope is rise over run. Negative 2, I like to put it over 1 to make it a fraction. That way I can clearly see what my rise and run is. A rise of negative 2 tells me to go down 2. A run of 1 tells me to go right 1. Then go down 2 again, right 1 again, down 2 again, right 1 again. And 4 points is more than enough. And it looks like that. All right. That's it for today's section. I'm going to come check in and see how you all did with the calculator stuff. If it didn't work out correctly and you couldn't figure it out, let me know so I can help you.